What's up, everyone? This is LeetCode 8, string to integer. So, in this problem, we're just given an input string s, and we have to convert this to an integer. Seems simple enough, but really the slightly tricky part about this problem is we have certain edge cases we need to account for. And once we implement the solution, you'll see this problem is not too hard. It's just handling all those edge cases can be a little bit confusing at first. Okay, so we're given an input string. Okay, and we have to convert it to an integer, and we have to implement that function to do that. And there's certain things we have to account for, right? First of all, we have to ignore leading white space. So, because we could have that, for example, look at this input string in example 2. We have a leading white space here, right? We have to ignore that. Second of all, we have to determine the sign because we're converting the string to a 32-bit signed integer, right? So it could be positive, it could be negative. So we need to determine whether this number is zero, or sorry, not zero, if it's negative or positive, because our actual integer has to be negative or positive also, depending on whether our input is positive or negative. Because keep in mind, our input is a string, right? Obviously. That's why we can have like leading white space and stuff. And we have to convert this to a integer, right? That's what our output should be. So we care about whether it's positive or negative. Now, if we don't have explicitly a positive sign or a negative sign in the actual string, just assume it's positive, right? So for example, something like this 42, just assume it's a positive 42, right? So yeah, we have to ignore white space, determine the sign. 3, we have to basically read the integer by skipping the leading zeros until a non-digit character is encountered or the end of the string is reached. If no digits are read, the result is 0. So what this means is, if you look at, for example, example 3, right? We have to read until either we encounter a non-digit character or the end of the string. So, okay, let's go. 1, 3, 3, 7. Okay, we hit this C here, right? This is a character, a non-digit character. So this is technically the end, right? We would basically exit, and we would return the digits we have so far, which is 1337, which is why the output here is 1337 instead of 133703, right? So this hitting this would terminate basically us going forward, right? We wouldn't check anything past this. Okay, so this really is like a few edge cases all in one, but kind of like in terms of how the conversion would happen, right? If we had just a bunch of characters with no numbers in the string, we would just return 0, right? That'd be like another edge case, right? We skip the leading zeros also. That's another edge case, right? Like for example, this negative 042, right? Obviously, we would skip the leading zero, so this input here would just be negative 42, right? Because again, we skip the white space, we skip this leading 0, and we account for these two numbers here as well as the negative sign, so we get negative 42. That should be our output, okay? And then the rounding part, we basically just want to make sure it's in bounds of the 32-bit signed integer range, right? Because again, we have to convert it to a 32-bit signed integer. And even if we weren't, I mean, this is just something they explicitly tell us, right? If we had a 64-bit or something, I don't know. This range is important either way. But because it's a 32-bit signed integer, right, we have to stay in the 32-bit signed integer range, the negative side and the positive side. And so we just basically, if we're outside of this range, we have to clamp it to whatever side we're on. So for example, if we're less than this number, we have to return this number. If we are greater than whatever this is in terms of our output, we have to return this. That's what it means by clamp, right? Okay, so let's handle this, okay? Again, this problem isn't too hard once you see the solution. It's just that we have a lot of edge cases to handle, and that's kind of the tricky part, okay? So first of all, let's start off by stripping the white space, okay? Because that is possible. We have leading white space. We could have leading white space, so let's handle basically ignoring that. And, right, it's possible the entire... we'll just say strip white space. Technically, remember, our input could have other stuff. It doesn't have to have digits, but we'll account for that. Okay, so let me see how we're going to do this. So the way we're going to do this is basically we're going to have an index, right? And we're going to call it I. And we're going to start at the 0th index, and we're going to move forward to build out our actual output, okay? So obviously we're going to start at the 0th index, right? And we're going to get the length of s, right? So we know how far up we should go. Okay, so basically, while I is less than n, and the actual character that we're on, if that's a white space, right, what we're going to do is we're just going to move forward, okay? So basically, as long as we're in bounds and the character is also a white space, just move forward, okay? Once we're done with that, now we need to check if the number positive or negative. Okay, so we're going to say the sign is initially going to just be 1. The reason I say 1, you need to understand, is at the end we're going to have some number we're going to store in some variable called result, and we're just going to multiply whatever result is by the sign. Because if sign, let's say the actual sign is like the character dash, like this, meaning it's negative, we would change sign to -1. So when we do result times sign, we would result would flip to negative. Okay, makes sense, right? Just basic math stuff. Okay, so initially we're just going to assume it's positive. But we need to verify that first, okay? But this is our initial assumption. So we're going to say if we're in bounds and the character is negative, then we need to do. Now, we don't want to move forward. We actually want to explicitly check if it's also positive. Because that can show that the reason we have to do this is because this plus sign technically can show up in our this plus sign can technically show up. Also, regardless of whatever sign we have to move forward in the index. But the reason we have to do this here is because technically our input could have the actual plus sign. So even though here, for example, we don't have a plus sign, so we assume it's positive. Here we don't have a plus sign. Here we don't have a plus. Well, we have a negative here. We don't have explicitly a plus sign. Our input technically can have this symbol, so you could have something in the string like +437, in which you're just supposed to return 437. Okay, so we need to actually account for this as well, because it can explicitly exist in the actual input. And if it doesn't, then it doesn't matter because sign will be 1, right? So if we don't enter any of these, it's fine. So if you have something like this, for example, we wouldn't enter the if because we have no negative. We wouldn't enter the else if because we have no positive. And we also wouldn't move forward in the I, right? Because if we're here, we have no plus, we have no negative, so we don't want to move forward. So sign would be 1, which is proper. That's what we should expect because it would be a positive number. But we wouldn't move the I forward, so we would still be at this 4, which is important, right? So this kind of handles all those edge cases where the input could be negative, it could be positive, or it could have no symbol, in which we just assume it's positive, and that's basically what this is for. Okay? Okay, so now we did that. Now we have to actually handle the digits. So initially we're gonna have a result. We're gonna store it to 0. Again, we need to have this because remember, if we have no if in step 3, right, when we're doing the conversion, if no digits are read, we have to return the result, which should be 0. So we need to make sure that's kind of our, I don't know if you want to call it base case or whatever, but that is our base case initially. Okay. So we're gonna say while we're in bounds, and the character that we're on, right, the index that we're on, if that's a digit, right, then we wanted to do result times 10 plus int of s of I. Okay, and then we move forward. So I'm going to explain what this is doing in case for some reason you can't comprehend it. You know, it's fine if you don't, but I'll just explain it anyways. So if we have something like this as our input, right, what we're doing basically is result initially is 0, right? So we're going to do 0 times 10 plus 4, right? So 0 times 10 is 0, plus 4 is 4, okay? Then we move over to the next index, which would be the second 4, right, in up here, right? We'd move to the second 4. So then we would do result, which is 4, times 10 plus 4, right? And that would be 40 plus 4 is 44, okay? Now we move on to the third digit, which is the 5. So result is what? 44 times 10 plus 5, 445. And what do you know? This while loop, this tiny little algorithm, I don't know if you want to call it an algorithm, but this while loop basically builds out our result, okay, as we go forward. Okay. So, and again, we would exit this while loop if we actually encounter something that isn't a digit. So, so for example, on example 3, if we're going forward, right? As soon as we hit this C, this is not a digit, so we'd exit the while loop anyways. So this accounts for those edge cases as well, right? And we would just return result, right? Because result is 0, and if we don't enter this at all for some reason, we just have result still be 0, right? So now here is where we have to check if the sign is in, well, before we check, well, we have to check if the sign is in range, right? Is positive, or maybe let me rewrite this. So convert result to proper, I don't know if you want to call it polarity. Yeah, I think polarity is the right word. But basically convert result positively or negatively depending on what sign is. And then clamp the range. Clamp the range if necessary. So we're doing two things really, right? First of all, we're taking result and we're basically converting it to the right polarity. I think polarity is the right word. If it's not, don't get mad at me. But basically, whatever sign was up here, right, if it's negative or positive, we want to make sure result is also that. So if result should be negative, we're converting it to negative. Okay? And then we have to do the clamping. So the way we're going to do the clamping is just some simple if statements, okay? So if result is less than whatever this is, right, -2 to the power of 31. So -2 power 31, right? If result is less than that, we want to just return this, right? Because we're clamping it, remember? Else if result is greater than, what is it? 2 to the power of, let me just do it like this. Maybe it's easier to read. Okay. So, and if result is greater than 2 to the power of 31 minus 1, if that's the case, then we just return 2 to the power of 31 minus 1. Else, now this else is basically a case where it's in the range, right? Like we don't have to do any clamping, in which case you could just return result, all right? So yeah, that should be it, unless I did some little mistake. Doesn't seem so. Now, this problem isn't too hard, like I said. It's just that there's just all these edge cases you gotta handle, right? So, I don't know. Maybe it's a useful problem. I honestly, personally, like I've said it before on the Grind 75 as we're doing these problems, I really hate these types of problems because I feel like you're just implementing stuff and handling like weird edge cases rather than solving something algorithmically. But I don't know. If you like these problems, more power to you, I guess. But I'm not a big fan of these problems, but it is on the Grind 75, so I'm doing it anyways. But anyways, I hope this helped, and I'll see you in the next one. Peace out.